morning class. It's been a while. I'm happy to see you. Hope you're enjoying your Easter. Briefly, we are going to complete our note on cleavage and implantation while we move over to the next topic. So, I'm not going to go back to what we've done already. You know what cleavage means, division of the zygote. I told you the other time once a zygote is being formed at day 1, the zygote divided into 2, at day 2 it divides into 4, at day 3. Once the 3 is being entered, it's divided into 8. That's in day 3. It divides into 16 cells that we call what? Morula. So, I'm going to give you a note because I gave you the explanation already. So, let's write. Subheading cleavage / implantation. After fertilization, rapid mitotic division of the zygote called cleavage takes place. At day 1, the zygote divides into 2. At day 2, the second cleavage is completed and the zygote divides into 4 cells. At the end of day 3, the fourth cleavage is completed and the zygote is known as morula and has 16 cells. The cells in the morula are known as blastomeres. Blastomere is spelling on the board. That is each cells. If you have a morula like this and you have many cells, each of these cells is being called what? Blastomere. Alright. The morula is still surrounded by the zona pellucida and is at the same size as the original zygote. What this sentence means that as the zygote is divided, it is not enlarging its size. It means still surrounded by what? Zona pellucida. Let me write. At the end of day 4, the number of the cells in the morula increases as it continues to move toward the uterine cavity. Around day 5, the morula reaches the uterine cavity and endometrial secretion called uterine milk enters the morula and creates a cavity called blastocyst cavity, and then the embryo is now called what? Blastocyst. Remember what I told you, that once the 5 reaches and this enters the uterine cavity. It's like this, and you have many what? Cells. So once the uterine milk enters, it's going to push these cells to where? To the periphery. So it will be something like this. The cells will be stacked right here, and you have a space here that is called what? Blastocyst cavity. And at this point, this is no longer called morula. This is called what? Blastocyst, because of the presence of what? The blastocyst cavity. Alright. And also the blastomere, right? And also the blastomere has been rearranged to form 2 distinct structures. Also, the blastomere has been rearranged to form 2 distinct structures. And these structures are, number 1, the inner cell mass or embryoblast. Number 2, the outer cell mass or trophoblast. Number 1, the inner cell mass or embryoblast. Number 2, the outer cell mass called what? Trophoblast. Number 1, the inner cell mass called embryoblast, and this forms the embryo proper. And number 2, the outer cell mass called trophoblast, which forms the fetal portion of the placenta. Very soon I'm going to teach you the placenta, and I'll mention the 2 distinct portions, the fetal portion and what? The maternal portion. Now, I'm wrapping because you have the opportunity of listening to the lecture again. Around day 6, right? Around day 6, the blastocyst attaches to the endometrium of the uterus, and this process is called implantation. And before this time, the blastocysts are shaped up the zona pellucida so that it will be free for the implantation. Remember, we say as the division takes place, the zygote or the morula is still surrounded by what? The single zona pellucida. Reason for this surrounding is so that the vicinity or the circumference of the vicinity that houses that blastocyst will be what? Will not be terminated by the outside environment. So it is when this blastocyst enters the uterine cavity, or when the morula enters the uterine cavity, becomes a blastocyst and gets ready for implantation, the zona pellucida is what? Shaped off. Alright? Let's write. At day 7, the blastocyst is still in the process of implantation. Implantation, remember, anything that begins and has to attach itself well, the way it begins, it has to be pushing itself inside. So at day 7, the blastocyst is still undergoing what? Implantation. And that is the aim of what? Week 1. Remember, week 1 starts from when? Week 1 starts from day 1 to when? Day 7. Week 2 starts from day 8 to where? Day 14. So I'm going to talk about week 2 right now. So subheading week 2. Subheading week 2. I'm not going to give you something too much, giving you what you can read and understand. Now, Many things happen during week 2, but I'm going to give you the major things that happen, because if I want to break every tiny things down, you might not be able to understand what exactly happened. So I'm going to give you the major things that happen at week 2. So subheading week 2 in brackets the 8 to 14. Subheading week 2 in brackets the 8 to the what? 14. The major events here are number 1, differentiation of the trophoblast. The major events here are number 1, differentiation of the trophoblast. The major events here are number 1, differentiation on the board of the trophoblast. Forget this grammar. Means the trophoblast, like means division of what the trophoblast. Number 2, formation of. Number 2, I'm listing the major events. I'm going to pick them one after the other. Number 2, formation of bilaminar. Bi means how many? 2. Bilaminar embryonic. Formation of bilaminar embryonic disc. Some people call it formation of bilaminar germ disc. Number 3 is formation of the yolk sac. Number 3, formation of the yolk sac. Number 3, formation of the yolk sac. Number 4, formation of the chorion, what we call chorion. Formation of the chorion. So those are the major events that happen at week 2. So we are going to pick them one after the other and start from differentiation of the trophoblast. So let's write at the 8th, the trophoblast develop into 2 layers. At the 8th, the trophoblast develop into how many layers? 2 layers. At the 8th, so we are writing at the 8th, the trophoblast develop into 2 layers, which are number 1, cytotrophoblast. Number 2, syncytiotrophoblast. The way I'm writing it, that's the way it appears. The cytotrophoblast are the inner part, while the syncytiotrophoblast is where? The outer part. So those are the 2 distinct parts of the trophoblast, right? The cells of this trophoblast also at the 8th start production of human chorionic gonadotropin. Spelling on the board. I said the cells of this trophoblast at the 8th also start the production of human chorionic gonadotropin. In bracket, abbreviation is small h, capital C, capital G. Now, let me say one or two about this hormone. Remember, after ovulation, the egg is out from where? From the Graafian follicle inside the ovary, and that egg enters where? The fallopian tube. Now, once that egg enters the fallopian tube, the remnants of that Graafian follicle start the production of progesterone. And this progesterone is what will keep the egg inside where? Inside the fallopian tube. Now, if there is no pregnancy or if there is no fertilization per se, what happens is the corpus luteum will degenerate, and once it degenerates, remember, corpus luteum produces progesterone, and once it degenerates, there will be decline in the production of what? Progesterone, and what you have is what? Menstruation. But now, if there is fertilization, the corpus luteum will also die a week or so. So, but at this day 8, the trophoblast produces human chorionic gonadotropin that rescues that corpus luteum from dying, so that there will be constant production of what? Progesterone to keep the pregnancy. So the human chorionic gonadotropin makes sure that the corpus luteum is not dying, and because of that there will be constant production of progesterone. So this continues until placenta comes at around week 12 or week 13 and start producing what? That progesterone. So but before the placenta comes to play, what happens is human chorionic gonadotropin is out from where? The trophoblast at the 8th, and do what? And make sure the corpus luteum is not dying, so that there will be constant production of what? Progesterone. And remember, this is the hormone that is being seen in a woman or the female's urine whenever she is what? Pregnant. Hope that analogy is not too difficult. Alright. So what I have is the cells of the trophoblast also at the A stage, the production of human chorionic gonadotropin, which rescues the corpus luteum from degenerating so that secretions of progesterone and estrogen can continue in order to sustain the pregnancy. Now we enter the next subheading, formation of bilaminar embryonic disc. Formation of bilaminar embryonic disc, right? Now, what you have to know, the trophoblast differentiate into two structures, the embryoblast also differentiate into two structures. So, right, also at the eggs, the cells of the embryoblast differentiate into two layers. The cells of the embryoblast differentiate into two layers, which are number 1, hypoblast, number 2, epiblast. Number 1, hypoblast, number 2, epiblast. The way I'm writing it, that is the way it appears. Right, a small cavity is seen within the epiblast, and this cavity is called amniotic cavity. A small cavity is seen within the epiblast, and this cavity is called what? Amniotic cavity. And it is filled with fluid known as amniotic fluid. It is filled with fluid known as what? Amniotic fluid. This is the spelling. Amniotic cavity and amniotic fluid. Now I'm going to give you a little function of this amniotic fluid. The little function I have here is number 1. It acts as a shock absorber. Remember, it is a liquid, so that liquid has the potency of withstanding any outside force. So in this case, the amniotic fluid acts, number 1, as a shock absorber. Number 2, it also regulates fetal body temperature. So remember, there is a liquid. The liquid has the potency or the affinity of maintaining anything temperature because it can make something to be what? Cool. Now number 3, it prevents desiccation of what? The embryo. Desiccation means dryness. It is liquid and it prevents dryness of what? The embryo. The number 3 subheading, formation of where? The yolk sac. I said it earlier, why I'm wrapping it like this, because you have the privilege of listening it over and over and over again. Alright. So the next subheading is formation of the yolk sac. Right. On day 9, the blastocyst cavity start developing into what? Yolk sac. So what you had, remember before implantation, you had something like this. You had cells like this and you have the blastocyst cavity. So on day 9, this blastocyst cavity is transformed into what we call yolk sac. And immediately when it is being transformed to yolk sac, that is when you don't call this thing again blastocyst. At the beginning, it has zygote from zygote. After it reaches 16 cells, inside you have corolla, from corolla you have blastocyst cavity. Now, at that way you have blastocyst cavity, remember you have embryoblast and what? Trophoblast. So, when the blastocyst cavity comes out, you start calling it blastocyst, and when the embryoblast comes out, you can also call it embryo. But, so, there is a time you can call it blastocyst, and you can also call what? Embryo. But immediately when this blastocyst changes to yolk sac, everything called the name blastocyst is off. You continue with the name embryo until you reach the fetal period. So what I have here is on day 9, the blastocyst cavity start developing into what? The yolk sac, which decreases in size as development progresses. Can you imagine that? Immediately when this changes to what? Yolk sac, what happens is, as development progresses, it does what? It reduces in what? In size. Moreover, it still have many functions. The first function is it transfers nutrients to the embryo while utero-placenta circulation is yet to be fully established. I'll give you a little explanation on that. Now watch this. What you have here is you have something like this, and you have the blastocyst cavity that changes to yolk sac. And this embryo is still trying to develop the connection between what? The placenta, like that channel through which the fetus or the embryo can grab nutrient from the mother. That is still in the process of developing. So when that happens, it is the function of this yolk sac to trap nutrient from the endometrium and give it to where? The embryo. Number 2 function is, it also functions as a shock absorber. Just imagine this. So it acts as a shock absorber. Then number 3, it also prevents desiccation of the embryo. Now the last but not the least subheading is formation of the chorion. Formation of the chorion. Chorion is spelled C-H-O-R-I-O-N. Formation of the chorion. At day 11, the chorion is formed, and it has these 2 functions. It has many functions, but what I have here is the major of its function. Number 1, production of HCG. Production of HCG. Production of HCG. Some people might be wondering, why is it producing HCG also? Remember, I said something that I don't think there is any function of the human body that is being carried out by only one structure. Reason is because if that structure disappears or dies, that means the function is dead. So at least we have 2 or 3 structures in the human body that perform a specific function. So the chorion also, remember, is coming at the level now to come and synergize the production of human chorionic gonadotropin with what? The trophoblast. So the first function is production of HCG. Second function is it helps in immune response. So that is all we have to know about what? Week 2. So now I move to week 3. The one major thing about week 3 is you can't just study week 3 alone. We study from week 3 to week 8. We study from week 3 to week what? 8. We study from week 3 to week 8. So I'm going to give you the major thing that happened. It's going to be very, very brief. So let's write. Stop reading. Week 3 to week 8. The major event here is the transformation of 2 germ layers into 3 embryonic germ layers. Remember, the trophoblast divided into 2 structures, cytotrophoblast and syncytial trophoblast. Also, the embryoblast differentiated into how many? Hypoblast and epiblast. So, those 2 bilaminar germ discs that we call hypoblast and epiblast is what is being transformed to how many layers? 3 layers. So, right, the major event here is the transformation of 2 germ layers into 3 germ layers, and this process is called gastrulation. This happened at week 3. Gastrulation. And the 3 germ layers are number 1, endoderm, number 2, mesoderm, number 3, ectoderm. The way I'm writing it, that is how it appears: inner, middle, and outside. Now, week 3 also marks the beginning of organogenesis, which ends at week 8. Now, this week 3, it is when the tissue that constitutes the organs that make up the system of the entire human body is being formed from this week 3 to week 8. But it starts from where? Week 3. So I have here that week 3 marks the beginning of organogenesis. Means, remember, organ, genesis means beginning. That means beginning of formation of what? Organ. Week 3 also marks the beginning of organogenesis, which ends at what? Week 8. So that is all you have to know there. So immediately when the embryo reaches week 8, now in the normal embryology, we're supposed to be picking one organ and tell you how it develops, but we don't need that here. Just know that organogenesis begins at week 3 and ends with week 8. When you enter second semester year 2, I will teach you nervous system, I will teach you development of the nervous system, and we'll make reference to this week 3. So week 3 marks the beginning of organogenesis, which ends at what? Week 8. Now, the next thing you have is week 9 to birth. The next thing you have is week 9 to what? To birth. Now, we form somebody. If this is how picking the form for her, woman, everybody from born picking. But it is well. So we've entered week 9 to birth, and this period is known as fetal period. Fetal what? Period. Remember, from oocytes, we have a zygote after fertilization. From zygote, at the end of day 3, you have what? Morula. From morula, day 5, it reaches the uterine cavity. Milk enters and is transformed to what? Blastocyst to what? Cavity. Embryoblast forms, and you call it embryo, or you still call it blastocyst. Now the blastocyst cavity is changed to yolk sac, and the name embryo continues. But once that embryo reaches week 8, the name embryo is wiped off. Now, from week 9 to birth, it's called what? Fetal period. And what happened in fetal period is all those organs that were formed in the embryonic period, specifically from week 3 to week 8, which is the period of organogenesis. All those tissues and organs and systems, their development continues where? The fetal period. So let's write subheading week 9 to birth in bracket fetal period. Is known as the fetal period and is characterized by maturation of tissues and organs that was formed during the embryonic period. That is that. So that is where we are going to stop. And fetal development, we enter into an interesting topic we call fetal circulation. Hope you are enjoying the class as usual. So we are going to talk about fetal circulation right now. We are going to talk about fetal circulation. Now, we are going to see why the circulation of the fetus is different from the postnatal circulation. Now, the little reason I will give you now is number one, in the embryo or the fetus, the lungs are not fully developed. Remember, the lung has to do with pulmonary circulation. Now, the liver is not fully developed. Remember, the liver and the GIT has to do with what? Portal circulation. And the heart is not fully formed. That has to do with what? Coronary circulation. So, the circulation of blood in the fetus is different from what's happening in the postnatal life. So, let's write fetal circulation. Is the circulation of blood in the fetus? Is the circulation of blood in the fetus? It consists of specialized structures that permit the exchange of material between the mother and the developing fetus. It consists of specialized structures that permit the exchange of materials between the mother and the developing fetus, connected through the umbilical cord. Connected through the umbilical cord. That means it is the umbilical cord that connects the the baby to where? To the placenta and then the mother. Alright, let's continue writing. The exchange of these materials occurs at the placenta. The exchange of this material occurs at the placenta. Now, this circulation differs from postnatal circulation because the lungs, the kidney, and the G and the digestive organs are yet to be functioned. It differs from postnatal circulation because the lungs, the kidney, and the digestive organs are yet to function. And also, what you have to know is this circulation at some point permits the mixture of oxygenated and deoxygenated blood. Now remember, when you are talking about blood flow through the heart, you'll be saying deoxygenated blood from the upper and lower extremities enters the right atrium through the superior and inferior vena cava. Now before I continue this, I will have to draw the heart so that we will now merge the two things together for better understanding. So, if this is the heart, let me just draw something. It's just a sketch. Let me sketch bigger so that everyone can see. If this is the sketch of the heart, if this is a sketch of the heart, what you have here is the right atrium, this is the left atrium, this is the right ventricle, this is the left ventricle. Then you have the pulmonary trunk coming out from here. You have here the superior vena cava, you have here the inferior vena cava, and you have the pulmonary trunk dividing into what? Right and left what? Pulmonary arteries. So the pulmonary trunk divided into what? Right and left pulmonary arteries. Now going to the left ventricle, what you have here is the aorta. You have here is the aorta. And the aorta comes out here. Alright, so if this is the human heart and you are talking about blood flow through a normal mature heart, you're saying that blood, the oxygenated blood from the upper and lower extremity enters the right atrium through the superior and inferior vena cava. And once blood reaches here and this contracts, the right atrioventricular valves opens and that blood enters the right ventricle. Once blood reaches the right ventricle, it passes through the pulmonary valve and enters the pulmonary trunk. And as the pulmonary trunk ascends, it bifurcates into two structures we call what? The right and left pulmonary arteries. This goes to the right lungs and this goes to where? The left lung. After oxygenation, the next thing is the blood comes back to where? To the left atrium through what? Pulmonary veins. And there is one similar thing between this postnatal circulation and what? The fetal circulation. In postnatal circulation, there is an artery called pulmonary artery that carries the oxygenated blood. Now also, if you go to fetal circulation, the artery we call umbilical arteries also carries what? The oxygenated blood. So if you see a question like which of these is synonymous both in structure and both in structure and content, so or maybe which of these arteries is synonymous in content and function to umbilical arteries in postnatal life, the answer should be what? Pulmonary artery. Why? Because pulmonary artery carries what? Deoxygenated blood, while umbilical artery also carries what? Deoxygenated blood. So now I'm going to just do a skeletal overview and run the fetal circulation for you, then we merge it together for a better understanding. Now, the way we will start the fetal circulation is this. First of all, write placenta. Just write placenta. And now, deoxygenated blood enters the placenta through what? Umbilical arteries. Deoxygenated blood enters the placenta through umbilical what? Arteries. Deoxygenated blood enters the placenta through umbilical what? Arteries. Deoxygenated blood enters the placenta through what? Through, this is umbilical what? Arteries. And now, once the umbilical arteries carries the oxygenated blood to the placenta, oxygenation takes place. In the prenatal life, oxygenation takes place where? In the lungs. But in the prenatal life, oxygenation of blood takes place where? At the placenta. Now, once umbilical arteries carries the oxygenated blood to the placenta and oxygenation takes place, the blood leaves the placenta through what? Umbilical vein. The blood leaves the placenta through what? Umbilical vein. Now, once the blood leaves the placenta through umbilical vein, the umbilical vein now divides into two structures. This is still the umbilical vein going. It divides into two structures. One little one, and this one is very big. Now, this umbilical vein divides into two structures. This one goes to the liver, and this other structure is called ductus venosus. This other structure is called ductus venosus, while this one joins the hepatic portal vein and enters where? And enters the liver. Now, at the end of the day, this ductus venosus goes to where? Inferior vena cava. At the end of the day, this ductus venosus enters the inferior vena cava, and also the branch from the liver still joins the inferior vena cava. And remember, the inferior vena cava empties into the right atrium. So this is inferior vena cava. The ductus venosus empties its contents into the inferior vena cava. Now remember, if this was supposed to be a normal postnatal life, what you will see is that from the GIT, blood enters the liver for what? Remember, liver is the real place for what? Portal circulation. Because anything that enters your mouth, it is regarded as like, even if you eat poison, it is as if you eat food. So that blood have to pass through the liver for analysis, so that if there is any bacteria, it will be killed by the macrophages of the liver. But in this case, while this umbilical vein divides into two bigger ones, into two structures, one very big, one small, is because there is no point of this blood going to the liver. Reason is because the liver at this point is not functional. So the blood enters the bigger ductus venosus and reaches where? The inferior vena cava. Now the one that goes to the liver also joins the inferior vena cava. So at this point you have what? The right atrium. At this point you have the right atrium. And remember, the superior vena cava also empties to where? The right atrium. So I said something that fetal circulation can be the mixture of oxygenated and what? Deoxygenated blood. That is not a problem to the fetus. So at this point, the deoxygenated blood from the superior vena cava joins the right atrium. Now, let us look at the heart. If we are talking about blood flow through the heart, After right atrium, blood enters right ventricle. After right ventricle, it enters pulmonary trunk. The reason for all this movement is because this is the channel through which blood enters where? The lungs. But to the fetus, there is no need for blood to go to the lungs because the lungs is not what? Functional. So now, at this point, the blood enters the right atrium. Instead of that blood to enter the right ventricle, it passes through in the fetus. There is a space here at where the interatrial septum that we call foramen ovale. There is a space at the interatrial septum that we call what? Foramen ovale. So now, instead of that blood in the fetus to pass from right atrium to right ventricle, it rather enters where? Rather enters foramen. Sorry, let me do something like this. Right atrium, from right atrium, what is small? If you are writing in your book, you write a letter, something that is more bigger than this. So from here you have foramen ovale. This foramen ovale, once the baby is born, is supposed to close. It is when this foramen ovale refuses to close, that is when we say that somebody have hole in the heart. So in a normal situation, the foramen ovale, once the baby is born and takes the first breath and blood goes to the lungs and comes back, is supposed to close this space. So in a fetal life, from the right atrium, it enters where? Foramen ovale. And remember, if foramen ovale is here, that means it's going to where? Left atrium. So from foramen ovale, you have the left what? Left atrium. This is where the left atrium is. And don't forget, since there is a space between the right atrium and the right ventricle, in the fetus, while most of the blood passes through foramen ovale to the left atrium, some still passes from the right atrium to the right ventricle. So while the majority enters foramen ovale, little from the right atrium enters what? The right ventricle. Hope you understand it. Little from the right atrium enters what? Enters the right ventricle. And once it enters the right ventricle, the next thing is the little that does leave, it's not as if it is much. The majority passes from right atrium to where? Left atrium. So that it will bypass this right